Keen what? Well, let's leave him alone. It's probably something you did. You might want to start writing that letter of apology. All right. So I wrote on the board. I sent an email out this morning. You guys are going to have a quiz on Thursday on 5.1 to 5.2. Okay. So that'll be Thursday. So basically that involves multiplying and dividing actually mostly multiplying polynomials. That's what we did. Multiplying polynomials and factoring by a common factor, as well as factoring by grouping. So that will take place on Thursday. So we're just going to spend a few minutes today finishing off 5.2, just a couple questions to go through. And then I'm going to give you some time to finish off that assignment from yesterday. If you're done it already, great. You can take the time or use the time to either get some other of your other assignments done that haven't been handed in, or spend some time reviewing for that quiz on Thursday, asking questions, whatever the case is. But if you have work to do, whether it's yesterday's assignment or previous assignments, you need to be doing that. All right? So you're not going to sit and talk the rest of the block. Almost all of you have something that needs to be done and handed in. Right? And if you're not sure, look on PowerSchool because it's all there. That's part of your responsibility to make sure that you're caught up in all your work. So example 4 on page 29 says Paula has 18 toonies, 30 loonies, and 40 quarters. She wants to group her money so that each group has the same number of each coin and there are no coins left over. What is the maximum number of groups that she can make? So to do this, what we're actually going to find is we're going to find the greatest common factor for each of these numbers. We have the numbers 18, we have the numbers 30 and 48. And we're going to find the greatest common factor, which is the largest number that divides evenly into all these numbers. And you can do this by doing a factor tree, which we have done before. You're going to break each number down to a product of its prime factors, and then you're going to circle the factors that are common to each of those groups, starting with the number 18. You need to find two numbers that multiply together to get 18. It doesn't matter what two numbers you start with, as long as they multiply to get 18, you're fine. For example, you could go 2 times 9. You could also go 3 times 6. It wouldn't matter, because at the end, you're going to get the same factors, the same prime numbers. So 2 is prime. Remember, prime numbers have only two factors, the number 1 and the number itself. The only thing that multiplies together to get to 2 is 1 times 2. However, 9 breaks down to 3 times 3. And now you've expressed 18 as a product of its prime factors. If you went 9 being 3 times 6 first, so there's the 3, then the 6 would break down to 2 times 3. You get the same 3 factors. It doesn't matter. Okay? The number 30. What are two numbers that multiply to get 30? 10 and 3? What were you going to say? 5 and 6? It doesn't matter. You will get the same answers at the end as long as you do it correctly. Right? So if we did 5 times 6, just because I like Jan more than I like Princess, so we'll use hers. 5 is a prime number, but 6 can be broken down to 2 times 3. So Princess said, what about 10 times 3? Well, that will work because 10 is 5 times 2 times the 3. So it doesn't matter. You're going to get the same 3 numbers on the bottom no matter what you start with at the top. So do 48 on your own. Break it down to a product of its prime factors, and then we'll check it. So what'd you start with, Emery? Sorry? 6 times 8 is 48, so that'll work. Some of you may have used it different. You might have gone maybe 4 times 12. That will work. Okay. I think 16 times 3 also works. It doesn't matter. You're going to get the same numbers at the end. But 16 broken into 2 times 3, those are both prime numbers. 8, you probably start by first breaking it down to 2 times 4. But then the 4 can be broken down further to 2 times 2. You have to write them all as prime numbers. So that was step 1. We broke each number down to its prime factors, and we want to find the greatest common factor. So just like when we were finding the greatest common factor from terms of polynomials, we did that by circling the factors that are common to all the groups. This is no different than factoring a trinomial, a polynomial with 3 terms, by taking the greatest common factor out. It's exactly the same. So all 3 of these lists have at least 1 2 in them. So we can circle a 2 in all 3 of these groups. All 3 of these groups also have at least 1 3 in them. So we can circle a 3 in each group. Peyton, can we circle any more? So what's your greatest common factor? Pardon? Yes. There's a 2 times a 3 circled in every group. Your greatest common factor, GCF, is 6. And so that means is that we can have 6 groups of coins. That's what that means. Okay? There will be 6 groups of coins. So you've got all these coins, right, to begin with. You've got 18 toonies, 30 loonies, and 48 quarters. You're going to divide them all out. In the end, you're going to have 6 piles of money. And now we want to know how many of each type are in each pile. That's what part B is asking us. So this first thing that we've all done is part A. The maximum numbers of groups that she can make, we figured out, was 6, because that's the greatest common factor. So part B, how many of each coin will be in each pile? Well, there were 18 toonies. So those 18 toonies are going to be divided into 6 different piles. So if you divide that by 6, that'll give us 3 toonies in each group. There are also 30 loonies. And again, those 30 loonies are going to be divided up so that there are 6 equal groups of loonies. And 30 divided by 6 would be 5 loonies. And the last one are our quarters, and there are 48 quarters, which will also be divided by 6. And 48 divided by 6 is 8 quarters. So that is how many of each coin will be in each group. There's going to be 6 piles of coins. Each pile will have 3 toonies, 5 loonies, and 8 quarters. So we've got the maximum number of piles because 6 is the greatest common factor of those 3 numbers. And now we know how many of each type of coin is going to be in each of those piles. They're all going to be the same. Each pile will have 3 toonies, 5 loonies, and 8 quarters. Part C then is how much money will each group be worth. So our 3 toonies times $2 per toonie gives us $6 in toonies. we have 5 loonies times $1 per loonie gives us $5. And then finally we have 8 quarters times 25 cents per quarter would give us $2. So if we add those up, we'll get $13. $13 is the total value of each of those piles. And once we know that, it's pretty easy to see what the total value of all the money is, because there are 6 piles of coins. Each pile, contains $13. So 6 times 13, I think, is 78. So that's how much money was there to begin with. Each pile has $13. There are 6 piles. So yeah, $78 would be the value of all the money altogether. Right? So here's an example of where we're using greatest common factor. Instead of greatest common factor of a polynomial, it's the greatest common factor of 3 different numbers, which we've done before. So this next question is similar. The students in Mr. Noyle's construction class have decided they want to build doghouses for their class project. The class will be split up into groups. Each group will construct their dog house with the same type and amount of lumber. Mr. Noyle has 24 10-foot 1x4. So what that means is they are pieces of lumber that are 10 feet long, and 1x4 means they're 1 inch by 4 inches. That's what that means. 1 inch wide, 4 inches long, not long, 1 inch high, 4 inches wide, and they are 10 feet long. And he has 24 of those. He has 32 8-foot long 2x4s, which are 2 inches by 4 inches approximately. They're 8 feet long, and he has 32 of them. And he has 8 sheets of plywood that are 4 feet by 8 feet. So most of you probably are more used to dealing with the metric system. That's normally what we use, but the construction industry, the trades industry, still uses the old imperial system. Lumber is usually measured just like this, right? The most common piece of wood is a 2x4. That's what is used to build walls for homes, garages, finishing a basement. Almost always 2x4s are used to build those walls. They're approximately 2 inches thick by 4 inches wide, and they come in different lengths. 8 feet is the most common because that will fit in the back of most people's pickup trucks. But there's longer ones. There's 10-footers. There's 12-footers. It all depends what you're building and how you're going to carry it. And then those 4x8 sheets of plywood, they're 4 feet by 8 feet. So when a home is being built, after the walls go up, they put plywood all on the outside. And then usually, especially on a garage, they insulate and then they put plywood on the inside, or maybe gyprock, which is often used if it's going to be painted. But they also come in 4x8 sheets. So the construction, the trade industry still uses the old imperial system. Plumbers still use it as well. Pipe, which is used to have water going through a home or sewer system in a home, all that stuff runs through pipes, and it's categorized by its diameter. There's 2-inch pipe, there's 3-inch pipe, there's 6-inch pipe. That is the diameter of that pipe, and it comes in different lengths as well. Okay, so we want to know the maximum number of groups of students that can build a doghouse. So again, we want to find the greatest common factor between 24, 32, and 8. That's what we're trying to find, the greatest common factor. So we can do this like we did the last one by breaking each number down to a product of its prime factors. And it doesn't matter what 2 numbers you start with. as your first product. As long as you do things correctly, you'll end up with the same numbers at the bottom of each of these lists. So 24, maybe you're going to say, well, I know that's 2 times 12. 2 is a prime number, but 12 is not, so maybe you say, well, I know that's 2 times 6. Or you could go 3 times 4. It doesn't matter. When you're done, you'll get the same numbers at the bottom. 2 is prime, but 6 breaks down to 2 times 3. So there's 24 broken down to a product of its prime factors. What would you start with for 32, Brock? I've drawn a blank. Can you help me, Shani? Sure, that'll work. Any two numbers will work as long as they multiply to get 32. So 4 times 8. Maybe some of you thought about 2 times 16. That will work. Okay. Maybe some of you thought of, well, that might be it. 2 times 16, 4 times 8. I think that's it. But the 4 breaks down to 2 times 2. The 8 would break down first to 2 times 4. And then that 4 needs to be broken down for our final step. 32 is actually 2 multiplied by itself 5 times. And then for 8, some of you may already know that 8 can be found by multiplying 2 by itself 3 times. 2 times 2 times 2 is 8. You could go 2 times 4, and then the 4 break down to 2 times 2. Okay? So now we circle what's common to all 3 lists. And if we look at this, the last number, the 8, has 3 2's in it. There are 3 2's in the middle list that we can circle, and there are also 3 2's in the first list that we can circle. Instead of doing them individually, nothing wrong with doing it this way, as long as you're careful. So this tells us that our greatest common factor is 2 times 2 times 2, which is 8. It turns out that the greatest common factor is that last number, the number of sheets of plywood. So our greatest common factor is 8, which again, that means that we are going to have 8 groups to build these, is it birdhouses? Dog houses, sorry. 8 groups to build 8 dog houses. Each group will build a dog house. So that is part A, the maximum number of groups of students that can build the dog houses. So part B, how many of each lumber type will each group have to work with? So for part B, if we go back up to the top, there are 24 1x4s. Divided by 8, each group will get 3 1x4s to use to build their dog houses. There are 32 2x4s. If we divide that by 8, each group will get 4 2x4s to use to build their dog house. And finally, there are 8 sheets of plywood. That would also be divided by the 8. which means each group would get 1 sheet of plywood. And those come in different thickness as well. Sometimes it's 1/4 inch, sometimes it's 1/2 inch, sometimes it's 3/4 or even 1/4 inch. We're not told what the thickness is, it doesn't matter. Yes, ma'am. Okay. So there's part B. That's how many of each type of lumber that they'll work with. And then it says, what is the total length of the 2x4s and 1x4s that each group will have to work with? So this is part C, the total length. Well, those 1x4s, we are told, are 10 foot. There's 24 of them. They're 10 feet long, and they measure 1x4, but they are 10 feet long. So they're going to have 3 of these times 10 feet per piece of lumber. That gives 30 feet of 1x4s that they can use. The 2x4s, there are 32, and they were 8-footers. So each of these 2x4s are 8 feet long, and each group has 4 of them to work with. So 4 times 8 will be 32 feet worth of the 2x4s. So they would need to know this because they need to know especially how high the doghouse will be. They will use the 2x4s to build the walls. So they need to know if they have a total of 32 feet of 2x4s, and they have to figure out how many it's going to take in order to build the walls. They'll have to know how many 2x4s will be on each wall and how high each one will be to make sure that they have enough. So once they figure out the dimensions, they can figure out how many 2x4s they need, what the length of the 2x4s they would need would be, and so that will help them determine the dimensions of that doghouse so that they have enough wood to do it. Okay, so again, there's another example of using the greatest common factor of numbers to help solve a problem. Sometimes you're going to be factoring polynomials, usually, but sometimes you just have to factor numbers to find the greatest common factor to help you solve a problem. All right, so we'll stop there. Remember that we've learned about factoring. It's the reverse of multiplying. You're finding things that multiply together to get what you start with. Right? It says here that if you multiply 5 times x plus 2, you'll get 5x plus 10. So that's multiplying. Well, if you go backwards, if you have the polynomial 5x plus 10, you can factor that by taking out a common factor of 5, and the other factor is x plus 2. Factoring and multiplying are opposite operations. And when we found our factors, we multiplied them out to make sure we got what we started with. They are opposite operations. Okay? Usually the common factor is a single term, but sometimes, as we saw yesterday, the common factor is a binomial. So we saw questions like that yesterday. So again, you'll have the rest of the class to finish off yesterday's assignment. If you handed it in already and you want to grab it back to go through it, make sure, by all means, you can do that. If you've got that done and handed in, you need to make sure that you have all your other assignments done as well. Some of you are behind. Okay, so you need to take the time to get caught up. Yes, ma'am. Yes, you can. Yes, sir. Yep. Just make sure you guys sign out, eh? Pardon me?